with the innovation, with what are the KPIs? Are we very far from the KPIs? All these things you will be able to see in the next 2 days, and based on that then we can see what we need to do further, because I often need to tell that now in the different events that I'm going. I said, guys, we still need research. Don't forget, we need research. Because everybody is starting to think, okay, it's mass scaling up, we're getting, I hear 100 of gigawatts, 200 of gigawatts. Yes, it's all necessary, but let's be very honest. Today, the biggest electrolyzer in the field in Europe is 10 megawatts. So we have 8 years to build 200 gigawatts, what I understood. I think that's a challenge. It's a big, what did Frans Timmermans, our executive vice president, it's a bloody ambitious target, and it is. And so to get there, we will need research, massive amount of research. Europe will not be able to do it alone. I mean, my budget, 1 billion euro, it's nice, it's fantastic. I mean, it was higher, it was almost nearly doubled than what I got, what we got in the FCH2, the previous JU, but it's by far not enough. So we will need to work together with the member states. This is crucial because they also have a lot of research money. So let's bring this all together, make sure that we align with the member states, and let's put it together and do more research faster, because aligning with each other will also lead us to faster results. So I count also on all of you to bring that message back to your home, to your ministries, to say, look, let's align what is also happening in Europe and vice versa. So now I would like to introduce, of course, my head of unit of operations and communications, but today, or it's mainly operations now, because she's really managing with her team of project officers and also the knowledge management, all those beautiful projects we have in Europe. Challenging projects, there are really some challenging projects as well. And she's really doing a marvelous job with her team. I really have to appreciate her enormously for her passion, because she's an enormous passion lady on hydrogen. She's been here for, I think, almost 20 years. I think not yet 20, but nearly 20 years she's working in hydrogen and fuel cells, always doing the research. So she's the right woman at the right place. So please give me a warm welcome to Mirela. Good luck. Good luck.
Thank you. Thank you very much, Bart, again, for your warm introduction. Really touching me again. So, good morning. Good morning, everybody. Happy to see, let's say, so many of you, although I believe the rest are lost somewhere at the ground floor, I believe. Looking at the number of the registrations and looking at the people present, I can only guess people are lost. So just to say that I'm really looking forward, and I hope more will join us. Just to also say that we prepared 2 rooms, of course, so there is another room, and at one moment we will split in 2 parallel sessions, and we'll go in parallel until tomorrow afternoon, when we will reconvene here for the closing. So a bit of house rules. At one moment, and I will tell you after the plenary here, we will split, and like I said, we will go in parallel. Another mention I wanted to have at the beginning is that the event is web streamed, so it can be also followed online. As you know, we are a public-private partnership, so of course we have a duty to the public that we share everything we do with them. Bart already mentioned we have a long existence, at least 15 years. It has also been mentioned yesterday. And at least 12 years of doing this exercise, research days or program review days, how you were used in the past. As of this year, also with our new, if you want, DNA in the Clean Hydrogen Partnership, we have been required to make sure that we have a consultation of the wider scientific community. And in that respect, we have a bit changed the concept. So in addition to just presenting projects, we would like also to invite every year, in every session, a scientist to a bit debate, discuss on how well is our program doing, Are we on the right path? Are we sufficiently inclusive? Is everybody there? Do we have to do something else? And I hope you will enjoy today and tomorrow this type of discussions in all the panel or in all the sessions that you will follow. This exercise, it's an exercise that, like I said, it has about 12 years, the program review. We do it with a great help and support of our colleagues in the Joint Research Center, and I would like to say it today here, to say a big thank to them. We will not be able to do such a thorough exercise without their help. I can tell you that their expertise is going deep down in every single project that we manage. And then they provide to us really technical insights and analysis for our program review, which culminates with the program review days report, which this year will be released about a month later in November, because our planning was, like you know, to do the PRD normally in November. So of course for the PRD it was impossible to release the report before. I go and now I get into the details. So it is my pleasure to present you the status of the program. You will see what we do. Yesterday we just got a bit of a glimpse through the policy conference. We do many, many things. We do not only support grants, we mainly support grants. Our budget is to support grants projects, but we do so many activities, and I think it is my duty today to just introduce you to the Clean Hydrogen Partnership activities. Next slide, please. Or it's me. Thank you. Good. So for those that get just now to discover our Clean Hydrogen Partnership or Clean Hydrogen Joint Undertaking, a small clarification from my side also on that. The two are correct. You can use Clean Hydrogen Partnership, you can use Clean Hydrogen Joint Undertaking. The joint undertaking is the legal name, the partnership is the communication name. So do not hesitate to use both of them, but I strongly recommend you please stop using CHP, CH2P, CA, whatever acronym you find that may fit us. No, we are Clean Hydrogen Partnership. There are only 3 words. I think we don't need to shorten them further. So please try to name us correctly and use the correct acronym. We are, like I said, an institutionalized public-private partnership. What means that? There are many partnerships that the European Commission is entering into. Some of them are co-programmed, some of them are co-funded. This one is an institutionalized, meaning we are an autonomous EU body with our own governance. A partnership between European Commission representing the European Union, and of course from the private side, Hydrogen Europe on the left side, and Hydrogen Europe Research. Hydrogen Europe with more than 300 members, Hydrogen Europe Research with more than 100 members. Representing, of course, on one side industry, on the other side research community, academia, research organizations. We are building on the legacy of the 2 previous joint undertakings. So we have received support, when I said 12 years, 15 years, that goes back to the 7th framework program, when the first time the European Commission decided to enter into a partnership with the industry in such an EU body. And we have received support over the years from the 7th framework program and Horizon 2020, and now from Horizon Europe, an additional €1 billion to commit until 2027 through calls for proposals, and to implement until 2031. You may guess why, because if we just launched the last project in 2027, 2028, we have to finish it by 2031. On top of, and it has been mentioned several times yesterday, we have received, through the communication of the Repower EU, 200 million to just support hydrogen valleys, with the aim to double the hydrogen valleys in Europe by 2025. It doesn't necessarily mean only to support grants. There are many activities to double the number of the hydrogen valleys by 2025, not only by supporting them with a grant, but also helping them with project development assistance, for example, or many, many other activities. You will hear from that if you stay with us, of course, today and tomorrow. As I said already, we are continuing the work of the previous two GUs. We have supported activities from across the whole value chain, from production, different routes of hydrogen production, of course, renewable hydrogen production. We have supported distribution, storage type of projects, and then end uses, and in particular, mostly for transport or stationary applications, and of course, cross-cutting type of activities. But we have also supported activities along the whole TRL spectrum, if you want, TRL, technology readiness level, from very low TRL type of activities, breakthrough type of research, up to testing, validation into the field of the technology, high TRL. In doing that, we supported so far 287 projects for a bit more than €1 billion already. So that in the previous two GUs. As I said, you can see the distribution across the value chain, across the different type of projects. This is also a bit of another look at how the projects have been supported. On the left side, you could see the contribution from the private members, also in the projects. I just want to stop here for a moment and to say that this is the funding that we have it in the projects, and the in-kind, you may be aware of that word, the in-kind contribution from the private members in the projects. On top of that, and I have not chosen to present it today here, because that's another matter, our private members are also contributed to our program through additional activities, the so-called IKA. All the details about that, by the way, you can find in our annual activity reports on our website. So feel free to go there and find all the numbers. You also see a nice spread across Europe, although we still have a lot of work to do in some parts of Europe. And we know very well where our weaknesses are, or where we are not extremely successful with projects. And believe me when I say that we do all our best to also have projects in all the parts of Europe. But while we build on the legacy of the previous GUs, we have changed a bit in focus. And when I say change a bit in focus, is by structuring our program, and that has been also shortly presented to you last year. We have structured our program around three main pillars, if I can say: production, of course, distribution and storage, and then end uses, with many other horizontal type of pillars, horizontal but also vertical, with many activities around the main core activities of the three pillars. We have many objectives. We have European Commission in particular, but in agreement, of course, with our private members, has put more pressure on us, if I can say. We have, if you remember, with the previous GU, we had only 5 objectives. And look at this. We have more. We have different levels of objectives, general objectives. And when you look at the general on the left side, of course, we should, with the budget that is given to the partnership, we should contribute to the Green Deal, to the hydrogen strategy, to all the policies, in all the policies that we matter, and we matter in many policies. We touch on not only energy and transport policy, we touch on research and innovation policies, we touch on industry policy. So on many, many other policies, and on all of that, we have to contribute, or we have to show an impact with our activities. But also specific objectives on the right side, and meaning on how to do what we are required to do, is of course by improving the technology and continue to improve the cost effectiveness, for example, efficiency, reliability, strengthen the knowledge, keep to the competitiveness of the European industry, keep the knowledge in Europe, etc. All these, how can I say, objectives that we should be aware of. And of course with that comes all our reporting, and I'll get to that in a moment. This is a bit another way to show off what we will do. And on production, we will mainly focus on electrolysis and some other routes of renewable hydrogen production. By the way, this is also extremely detailed and well described in our Strategic Research and Innovation Agenda, SRIA, on our website. On production, on distribution, excuse me, on distribution, we will move or extend, better to say, extend our activities from the compressed hydrogen and hydrogen refueling station in that respect support in the past. We will extend it to other hydrogen carriers, such ammonia, liquid organic, even liquid hydrogen. We will also do more activities on storage, above ground and underground large-scale storage. And of course, we will look also at, continue looking at compression, for example, metering and all the purification, all the issues related to distribution of big quantities of hydrogen from point A to point B, and develop all the technologies, of course. On the end use, we will continue with the transport and look at where the technology could be used in transport, and we'll focus mainly, and again you heard yesterday in some of the sessions, to develop the building blocks, how we call them, meaning the stacks, the systems, and the tanks, for example, for heavy-duty applications, and then work in synergies with other partnerships, parts of Horizon Europe, in, for example, demonstrating trucks, heavy-duty trucks, in demonstrating waterborne solutions, ships, rail, and even aviation. You heard yesterday our plans with our colleagues in Clean Aviation GU. On the heat and power production or use of hydrogen for heat and power, we will continue working on fuel cells for stationary applications, and we will also open our program to other solutions, such as use of hydrogen in turbines, boilers, and burners. That has not been done by the previous JUs. We will open into doing that, and again, working in partnership with, or in synergies with some other partnership in Horizon Europe, such as, and again you heard yesterday, the steel partnership, the P4P, Made in Europe, so many other partnerships. And of course, all the other horizontal cross-cutting activities. We will continue working on safety, pre-normative research, education, training. Hydrogen valleys is going to become more and more a very important pillar, I think, soon. We will work on the supply chain, and of course, in agreement with our member, Hydrogen Europe Research, we will also put in place few strategic research challenges which will deliver by the end of the program for the next generation of products. You know already we launched the first call this year in doing that, and it was the biggest that we launched so far, 300 million. For that reason, we decided, for the entire community, not only for our program to manage, but we decided to split it into deadlines. And the first one was in May, the second in September. The one in May, we have already performed the evaluations in the summer. Results have been announced to the applicants in September, and we have started the grant agreement preparation. We hope to sign the first grants by the end of this year, so in 2-3 months. For the second deadline, we received the applications in September, and we are currently evaluating them, hopefully to finalize the evaluations in November and announce the applicants of the results this year. More than that, you can imagine I cannot say. The process is still ongoing, and those that were lucky or did a good job, they know already where we are. I mentioned several times we do much more than supporting grants. So I mentioned also we work in synergies with other partnerships, with other programs. We contribute through our pre-normative research to standards. We have a hydrogen safety panel, and we plan to create a sustainability and circularity panel. We have an entire team of knowledge management for reporting, for trying to, how can I say, monitor all our key performance indicators related to all the objectives. I can just, for your information, tell you that in the previous GU we had 2 specific indicators for our GU added to the Horizon Europe indicators. This time we have 20. So just for you to know how much we have to develop instead in program monitoring and reporting. I understand it's public money. We have to show impact to the EU citizens. Huh? And I think with 2 indicators, probably we were not able to show enough. And of course, we help support our public member, European Commission, in their international cooperation, and in the bilateral agreements that they have, in the different associations, such as Mission Innovation, IPAG, International Partnership for Hydrogen into the Economy, or the International Energy Agency task, and there we support the European Commission in particular by contributing to this task with our colleagues in the Joint Research Center. And of course, we do a lot of communication, including this event. I mentioned synergies, just for you to show you what is our daily life in ensuring synergies. I mentioned we mainly support grants, but all these grants have to be supported in a bigger picture of support of research and innovation in Europe. Huh? And you also heard yesterday there were at least 2 sessions dedicated to synergies. And on the left side, you see the synergies we have to ensure within Horizon Europe, with the other partnerships, which I already mentioned, with the Horizon Europe program itself, but also some other partnerships. They are like us, GUs, like Clean Aviation, so with their also work programs. And there is a lot of planning, discussions, to make sure that we align our roadmaps, like the director of CAJU was saying yesterday, but we also manage to implement them. And then on the right side, you see all the other type of funding and funding programs that we have to talk, and we did, in fact. And I just want to mention in the call 2022, the examples of, first, ensuring synergies with the Connecting Europe facilities. And you may have noticed already that we published 2 topics in which we plan to support the vehicles, the trucks and the vessels, and Connecting Europe facility was planning to support, or is planning to support, the infrastructure, the hydrogen refueling stations, through the AFIF, Alternative Fuel Infrastructure Program. Another topic I want to mention from the call 2022, and that will happen every year, is the support to hydrogen valleys in synergies with national and regional funds. When we support the hydrogen valley, we do not support it, not even 70%. The 70%, of course, is the maximum because it's an innovation action per se. But we do not support that. We normally support about 20–30% of a valley. And there is a lot of financial and funding engineering behind, and there's a lot of other support coming from other sources, like I said, national or regional funds, cohesion funds, etc. And there we have to, from the level of the planning, we have to ensure that, and I can tell you that requires a lot of effort, and it's not always successful, unfortunately. Anyway, it looks like, before I go to the next slide, it looks like we will have a success with CEF. And from the first deadline in the summer, we are, in fact, preparing the grant for trucks, and CEF is preparing at least a grant for refueling station along the TEN-T corridors. You will hear more from us in January, February next year. I mentioned already the regions. I mentioned how we work with the regions. That we started in 2017. So we are not talking about valleys this year. We are talking about valleys for at least 5 years. We started working with the different regions. We had about 100 memorandum of understanding signed with regions and cities when they showed the interest to work on hydrogen, to decarbonize their regions, their cities. At that time, we came with a report in 2017, 2018, and we identified 3 different streams in which we have to continue working with regions and cities, or working locally. There are regions that are very advanced. They know, they have their projects, they are ready to come, develop a valley, get support from us, get support from other sources. But there are regions that need other type of support. They are not yet there. They need either project development assistance, where they need support from us, which we give with the PDA, type of consultancy support to develop their project. And then later on to go to the next stages, maybe even at that stage, not even applying for funding. And there are regions which need still to understand the technology and what exactly is there for them to develop their project. So for which we still need to continue to do awareness type of activities, trainings, etc. So there are different streams, and that's why I said that in working with regions and implementing and trying to double the number of the valleys, we have to do different activities, not only support H2 valleys projects. This is only the tip of the iceberg. Yeah, just to show you a few examples of the valleys. You will hear them presenting, I believe, today. Yeah, I see I'm just looking at my project officer. And you will see them presenting, and you will also see they're presenting more details about the project development assistance, about everything we do on valleys. So please, if you are interested in that, follow the session on the valleys. But here, just to show you our funding, and our funding, it's really small as compared to the objective we have. Because when you say double the number of the valleys by 2025, what does it mean? To double the 4? No, we are aiming to 50. So that's why I'm saying we just don't support and finance grants. We have to do much more to get to the 50 valleys by 2025. 2025 is almost tomorrow. It's the day after tomorrow. We supported Big Hit in the Orkney Islands. That was the first idea. We didn't even call it valley. We call it hydrogen territory at that time. And in the end, it became, yeah, that's what we want, and that's what we mean by a valley. And then, of course, our first valley, which was also, I'm proud to say, was last evening awarded the Valley of the Year. The first valley was the Heaven project in the Northern Netherlands. That's our first support into a valley. And then it followed the Green Highland, which is the island of Mallorca. And I'm sure the island of Mallorca was shortlisted, by the way, for the awards, but it's not yet there. And I'm sure they will get the award probably next year. And then, of course, the last one, it's our initiative internationally under the Mission Innovation. And without staying too much on that slide, just to tell you that indeed, when starting and working on the valleys, the partners around the globe realized, okay, that's a very good idea to implement the hydrogen economy. I think it's the best business model. And I heard recently in one presentation, and I like it, saying that by implementing hydrogen valleys, you somehow also solve the issue of chicken and egg, because you have into a valley the production and the use. So I believe, yeah, you can agree or disagree with me, but I believe it makes sense in general terms. We can get into the details and debate it, and by the way, again, do so by following the H2 Valley session and comment on it. In doing that and talking with our international partners under the Mission Innovation, we identify all the valleys, and by the way, h2v.eu, it's the link to our valley platform under the Mission Innovation. Currently, there are 38 valleys around the globe mapped. We identified 3 archetypes, and we believe these are the archetypes of the valleys so far, also by seeing them into our projects. There are some projects mobility focused, small and mobility focused. Some projects a bit more bigger and more into the industrial type of uses, like hydrogen as a feedstock for refineries, for steel, etc. And they are very complex. The third archetype is the very complex type of project, the real big valleys, how we call them. Okay? So again, if you want to learn more, please go there. We updated the report for the Pittsburgh event of the Clean Energy Ministerial Mission Innovation. And we plan, by the way, to relaunch this platform. And currently, we are talking with about 200 potential valleys around the globe to see and how to update the platform and to relaunch it in January, February also next year. This is a pledge for the valleys. Whoever believes has not been contacted by us, you have a valley there in making, please come to us. All valleys that will be recognized will be also given a label, the label on the left. There will be recognized valleys. And of course, like I said, every year, we will give a Valley of the Year award to those that pass the financial investment decision. The other stream of working, the project development assistance. This we started in 2020. More recently, I have to say. And this is where we published a call for expression of interest. So that's how we start here. It's not a grant, it's call for expression of interest to receive help to develop your project. And I think we had very good, successful examples, and we supported 11 regions or cities from the first, if I can say, wave of supporting project development assistance. And right now, we are in project development assistance number 2 for cohesion countries. I mentioned at the beginning, we need to do something to make sure that our support goes across whole Europe. And for that reason, we noticed that the cohesion country needs a special support. So we put in place a project development assistance for regions in cohesion countries. I want to say also another thing. Project development is not necessarily only for valleys. It's for developing projects. Some of them may be a valley, but some of them, and in the first wave, we noticed some of them are not necessarily valleys yet. We have received a good number of applications again. We will send some news around, probably. I'm not sure if we will be able to do it today or probably next week. We received about 23 applications. And we intend to select, ultimately, 15 to be, again, provided consultancy assistance to develop the project. I mentioned that we continue to work on sustainability, circularity, and manufacturing, of course, but also on the supply chain. And we will come up by the end of this year with another tender to somehow refresh our study done also in 2017 on the supply chain and manufacturing. I have to mention this because sometimes, people forget. Our previous supply chain study in 2017 was the basis of launching the Clean Hydrogen Alliance. So our study provided to the European Commission was convincing them that there is supply chain and value chain in Europe in order to launch the Clean Hydrogen Alliance. There is a strategic value chain on hydrogen in Europe. We realize this is old. Many things have changed. Hydrogen sector is extremely dynamic, and I think that study needs to be updated. By the end of the year, we will do that, and we hope also to get with it some more features in help of our private members, in particular the industry, of course. We will continue with the safety panel, of course. Again, we see value in having a group of experts guiding us, the program, but also the projects on safety issues. We will continue doing and working on guarantees of origin and certification. You know that this is a very ongoing, controversial sometimes subject. And we need to support our public member this time, Commission, in particular in their development of policy and Renewable Energy Directive and their delegated acts in this case. We have a tender, and that is where we work every year and progress with such work. We publish every year, we continue working, we publish every year good fact-based studies. On the left side, it's what's coming from the observatory. We have an observatory. We plan to continue working in the observatory. We will sign a new tender for the next 4 years, working also with the intelligence unit of our private member, Hydrogen Europe. You saw their monitoring report that they launched 2 days ago. That was in also with the data that they provide to our observatory. Of course, I mentioned the Hydrogen Valley updated report for Pittsburgh, the one under Mission Innovation. And another one we did this year, it's the impact on battery electric vehicles and fuel cell electric vehicles infrastructure. I recommend you also to read that report. It's a very good report. Look at that and how and what will be the best and what's the impact of developing the two infrastructures all together. How shall we do it in Europe in general, and what will be the best approach in doing that? I mentioned the knowledge management, everything we do to monitor the program. We, in particular, the annual program review. And here, the only thing I want to mention is that with all the tools that we have, I mentioned observatory, program review, everything we have, and you know we also have a database where we monitor the progress of the technology, yeah? The database, the trust database. With all the tools, we want to integrate them. Currently, we are working on an architecture to integrate them into the EU Knowledge Hub on hydrogen. You will hear from us more, hopefully next year. I don't go through the KPIs and how all these are interlinked. I mentioned that there are 20 linked to this. The program review, I also mentioned the support of our colleagues in GRC. Sorry, I will have to go a bit quicker because I'm too long. I like to talk a lot, you know that. We will publish, as I said, in about a month, hopefully, the program review of this year. Please have a look on the event website. We have already published the project's fact sheets. So you will find, for each project, a fact sheet. We call them in the past posters. It's not anymore a poster. We don't hang them anywhere anymore. So let's call them project fact sheets. The observatory, I mentioned it to you. Feel free to go into the observatory. It's a lot of information. It's especially linked to the market. And that's why the work with our private members there. We have developed the hydrogen refueling station availability system. You know, we try and to give all the information to all the cars manufacturers to know when a station is available, or if it's not available, why. And it's a very nice map in there. And some of our, indeed, car manufacturers are using the API behind that our project provides. Yeah, this you have seen last night. This is our work along the project. Identify success stories, identify innovations, open it to the public, do the awards. And here I'm coming with other types of indicators that we follow. Our projects, and you know very well, you will hear also from some of them presenting. In order to show, and I think here we have to do, to continue to do this, I'm not saying we do not do already well dissemination and exploitation of results of research projects, but I think we have to do even more. I think for us Europeans, it's not, how can I say, we are probably, and this is my personal opinion from my experience, we are not used to acknowledge necessarily the support we are giving, or to talk very much about our results. We are not so used in Europe, like in other parts of the world, to be proud of what we do. And this is exactly where we push our projects to disseminate, to exploit, to communicate, because we feel that it's not enough. We have done a survey, and we do it every year with the program review through all our projects to see how many projects are doing exploitation, dissemination, conferences, etc. I'm not going to go, scientific publications, of course, patents, and all these things. What comes out of our projects that impacts the public? I'm not going to go through all the details. My presentation, of course, will be available. We will put all the presentations on the website after the event. But just to show to you There are many things happening in our projects, not only developing the technology, but our community has started to learn better and better how to exploit the results. I'm going to go through and also present them to the different conferences through the dissemination activities. And finally, I'm getting to the final of my presentation. You may have seen it in one of the objectives at the beginning. We got a new objective, a new thing to do. In addition to supporting grants, knowledge hub, etc., I just mentioned to you, we also been given the task of increasing the public awareness and acceptance of technologies. I will say extremely challenging task. In doing that, you can imagine that in the 10 years to come, or even less than 10 years we have now, we have to see where we are. Honestly, at this point in time, I don't know what's the perception of the public about the hydrogen technologies. So what we are doing currently, we are doing a public opinion survey. It's ongoing. We have sent a survey. We are doing it with Gallup, by the way. That's the contractor. It's a contractor that does for the European Commission most of the Eurobarometers. So you may be used to that. And I am proud to show to you just few preliminary results. We are not yet there. We are still digesting the results. But just to show you quickly, where is the public in terms of hydrogen technologies? So, when you ask them if they have seen, read, or heard anything about each of the following energy sources, you can see that the hydrogen is almost there, like the other of renewable technologies. So, the public knows about hydrogen technologies. Really, I was surprised. I was surprised about that. On the right up, you look at hydrogen as compared to what is in there. I don't see very well. Geothermal, biofuels, hydropower. It's almost there, like the biofuels. The public is aware about the hydrogen technologies. When you then ask them, have you seen, read, or heard anything about each of the following energy sources, in particular hydrogen, you see the distribution per countries, and you see very good numbers. Again, my presentation will be available to you. But you see also the average in the EU is not so bad. Again, and you see then the distribution on the right side, down, between female, male, and per age and education. So you will see very, very good results in this. Huh? By the way, we plan to come out with that, not sure this year, but probably again beginning of next year, with the results of such study, and then an analysis of what we need to do to increase this, of course, because as I said, this is our task. And then, another question was, have you personally or at your working place experienced any of these hydrogen applications? No, people do not. They have never come in touch with these technologies. This is very low, you see, on the right side. Yes, they heard about it, but they have not experienced them. And it's normal, our products are not yet there, or they are starting to get there. But then, when you ask to what extent do you agree or disagree to the statement regarding hydrogen energy and technologies, that hydrogen is a good solution for reducing the energy dependence of each country, they agree hydrogen is a solution. So they heard about it, they haven't touched it yet, but they agree it's a solution. So I think we are on the right track. With that, I just want to tell you again, please follow us today and tomorrow. We will continue now with more presentation on the portfolio of projects. Our team will get more into the details now this morning. And then we will go into the different parallel sessions. I illustrated them here. There will be another room for the right side of the parallel sessions. The left will stay in this room. And then hopefully tomorrow afternoon we will have nice takeouts. And all the outcomes of these 2 days will be, like I said, hopefully reflected in the program review that will be launched in about a month. Thank you very much. I'll catch up with the time, I promise, but I believe all of these were extremely important for you to understand what we do and how we try to show the impact of what we do to our EU citizens. I hope you appreciate that. Thank you very much. Now, I would like to ask, before the coffee break, of course, we will break at one point in the morning, but I will ask my first two project officers to join me on stage. And I would like to ask Nikos, for those that know him, Lymperopoulos, project officers on hydrogen production, and Dionisis Tsimis, I have a very Greek team on that side, on distribution and storage. Please take a seat, and Nikos, please go into your first presentation on production.
Right, thanks very much, Mirela. And good morning, ladies and gentlemen. Oops, going too fast. Right, it's really nice to be meeting you in person after many years, very long COVID years. Also very nice to have people online still following this event. My name is Nikos Lymperopoulos. I'm project officer at the Clean Hydrogen JU, following mostly hydrogen production projects, along with my colleagues Dionisis, Tsimis, Claudiu Pavel, and Eleni Atanasiu, who recently joined us. So I'll try and breeze through now, because we're running a bit short. Hydrogen production projects. Already mentioned that tomorrow 4 of these projects will be presented to you. Please join us. And before going to the proper part of the presentation, I have some great news to share. 3 of our large electrolyzer demonstration projects completed their very nice facilities in 2022, and they are now in the commissioning and testing and debugging stage. At the left-hand side, it's the 3 megawatt alkaline electrolyzer of the Demo for Grid project installed in Austria. The facility is very complete with storage and use in a oil heater, 1 megawatt thermal. Top right, it's the Aeolus facility at the northern tip of Norway. It's, this is the building you can see there. There is a 2.5 megawatt PEM electrolyzer directly fed by a wind park. This must be the northernmost hydrogen for energy facility in the world, I think. And at the bottom you can see the Refine facility, a 10 megawatt PEM electrolyzer installed in Germany in a refinery. You can also see all the JU staff. We did our away day this year there, and just to point out, the chimney you see at the back is not part of the project. Right, so hydrogen can be produced from water and can be produced from hydrocarbons, bio or fossil hydrocarbons. As you can see from the orange circles with the numbers there, we only support projects related to renewable hydrogen production. And the numbers clearly also show that electrolysis is the main technology that we are supporting. I have 3 slides with some statistics I would like to share with you. This first slide, left-hand side, you can see the support we've been providing over the years for different types of electrolyzers, ever increasing, especially if you consider that in the recent years, support is coming from other frameworks as well, like 90 million from the Green Deal. In the center, you can see the cumulative support, so PEM electrolyzers receiving most, followed by solid oxide and then alkaline. And to the right-hand side, very interesting, how our funding for electrolyzers was distributed to the type of beneficiaries. The red is SMEs, blue is industry, heavy industry, and then more than a third went to research institutions and universities. There used to be a concern at the past that maybe a JU would be supporting industry mostly, but now you can see it's quite well balanced. Now, the JRC is using this tool, TIM. This is a snapshot of our low temperature electrolysis projects. There are 11, And you can see, I hope you can see on the left-hand side, the participants to these projects. The size of the circle shows how many, and the links how interlinked. We can see that they're quite dispersed, which is a good sign that knowledge and expertise is widespread in Europe, and there are companies like Sintef and ITM mentioned with 3 projects each over these 11 projects. If we go to the high temperature, we can see that this universe is much more convoluted. It shows that expertise is more concentrated for high temperature electrolyzers, with players like CEA participating in 5 projects, if I can make this out, as an example. Enough of the statistics. Let's go to the project, starting with the low temperature electrolysis demonstration projects. I think you have seen this a number of years. We use this slide. Over the 11 years, we've seen that in our large electrolyzer projects, capacity of electrolyzers increased 500 times, while our funding per installed megawatt was reduced by 100 times. That's very impressive. Clearly, economies of scale, increased commitment from the beneficiaries in our projects, but also, we hope, improvements in CapEx. So, 3 of these projects are completed, 3 are currently being in the early demonstration phase, 1 Jewels still in development, and the 3 Green Deal projects have just been launched and they're approaching the financial investment decision stage. Now, these projects led to this very interesting feedback loop at the top, where electrolyzer OEMs really had to improve their products going into industrial sites. Industry familiarized themselves with these new electrolyzers, the effect being that we've established a solid basis on which to build the EU hydrogen strategy. The electrolyzer OEMs were very open, we saw, collaborating with the European Hydrogen Safety Panel on safety issues for electrolyzers. And I would like to make a special mention to the H2 Future project this year. It's completed, and they have achieved incredible figures. So they developed Siemens, a 6 megawatt atmospheric PEM electrolyzer, feeding a steel industry, a stack efficiency of 83% high heating value for hydrogen, purity of 99.9 prior to any purification step. They tried to operate electrolyzer from 15% capacity to 150%, the limiting factors being the balance of plants rather than the stacks. They provided electricity balancing grid services, and they incorporated special software to foresee how costs would evolve to reduce the hydrogen cost from down to 25 to 50% from operating normally. And they produced, over their testing, more than 800 tons of hydrogen. Besides all this, excellent outreach to the public, all the way to ministers, and the Commission really helped promote the hydrogen cost to the energy policy. So, from the project officer of the project, a thumbs up. This project is going to be dearly missed. Very, very good project. Excellent work also being done from our research projects, project meeting the various targets. On the left and bottom left, you can see the energy consumption at stack level for alkaline, to the right PEM for the research projects, and for the commercial electrolyzers that we use in the HRSs. You can see that our research projects are more efficient electrolyzers, especially for alkaline, compared to PEM, also showing the targets in the MOPE and the SRIA. At the right-hand side, it's current density. We're already there. The average is above 2.4 amps per square centimeter. At the bottom, we have supported the standardization of testing protocols for electrolyzers, project QualiGrids, but also the JRC effort already completed for low temperature. They're now working on high temperature testing. Few examples of our projects, 2018 projects, game changers, projects Neptune and Pretzel, aiming to develop 25 kilowatt 100 bar electrolyzers, quite challenging. The projects really struggled, I have to admit. They managed to develop cells that went up to 4 amps, even 8 amps per square centimeter for Neptune. Pretzel, 6 amps, so very impressive figures, but indeed challenging. And indeed, currently, we had a topic on highly pressurized operation of electrolyzers that was aiming for 50 to 80 bar, and we have 2 projects that were successful and are currently in the process of signature. 2019, 3 projects running in parallel supporting research on anion exchange membrane electrolyzers. Projects are getting there. They've developed hydrogen and oxygen evolution catalysts. They're now moving into testing these functional materials. They have jointly developed testing protocols for anion exchange membrane electrolyzers and also a hub on the internet for information. And yesterday, for those who were there, Project New Eli received our Best Innovation Award. Congratulations to them. The most recent efforts we have and projects is Project Oyster. This is a 1 megawatt PEM electrolyzer being designed for marine offshore applications. For the time being, this is going to be near shore at a port. It's also going to be designed to do wind turbine following, and it will have an integrated desalination unit. I'm also mentioning Project Hipster. It's basically hydrogen underground storage. You'll be hearing from my colleague later on this, but it has an electrolysis component. There's a 1 megawatt electrolyzer there. Moving on to high temperature electrolyzers, similar trend, growing from Project Green High 2 to Multiply. We are moving to the megawatt scale for solid oxide electrolyzers. Similar trend in decreasing the cost, increasing the capacity. The feedback loop on the left is the same. This time I would like to make special mention to projects Green High 2 in what they have achieved in terms of capacities, very high efficiency provided there is a heat input of 6.5 kilowatt hours per kilogram, the current densities, and for me this consortium did really a fantastic job, because Green High 2 are the only 2 projects that I know that were completed on time and met their targets. It's rare. So another thumbs up sign from project officers. A lot of research work being done, Project Gamer, proton ceramic electrolyzers, Project Reflex, met various targets at components level, and now it's the last stage of incorporating everything into a system. Project Switch, I'm going a bit faster here, and now moving still in water for producing hydrogen, but using concentrated sunlight. We have been supporting, even since the framework program 5, I think, Hydrosol, a family of projects that eventually has gone up to a platform in Almeria, 750 kilowatt thermal. A number of challenges. Still the material is there in terms of 150 cycles of testing, but need to increase the efficiencies through measures like, maybe you can see at the bottom right, the 3 reactors before and now, better insulation. We're talking temperatures 1000 degrees C, and advanced heat exchangers. There is the low temperature also production of hydrogen from sunlight, the photoelectrochemical devices. We've supported those to go up to 10 square meters and go under the sun. And this topic is going to be soon in our next calls for proposals. The last slide is producing hydrogen from hydrocarbons, either biomass or biogas. On the left-hand side, you can see, first of all, our projects are quite old, completed since some time now. Gasification of dry biomass or wet biomass and fermentation. And most probably there's going to be a topic on this, a flagship project for hydrogen production from waste at quite a large scale. It's going to be a flagship project. To the right-hand side, we were focusing on biogas without prior CO2 removal, producing hydrogen from this biogas project, Bionico, and Biorobur Plus. In conclusion, our research projects, electrolyzer projects, we've seen that the best-in-class electrolyzers have met even the 2024 KPIs. But please note, not all the KPIs at the same time. So you meet some of the KPIs, and you have to sacrifice some of the others. So there is work to be done. Our large demonstration projects prove that electrolyzers are a reliable partner in the sectoral integration and really helps bring renewable hydrogen to the center of the EU energy and environment policy. Under the new framework program, Horizon Europe, there will be more ambitious cost performance targets, improvements in manufacturing, recyclability. We want to keep EU leadership in electrolysis. We're going for even larger cells, stacks, systems, and different application areas. And lastly, the alternative routes. Yes, more support needs to be provided to this field for them to reach market readiness. And with this, I would like to thank you for your attention.
Thank you. Thank you very much, Nikos. I hope you hear me. And sorry for putting pressure on you. Because, as always, I have too many things to say. And please, Dionisis, please follow up Nikos. And let's see from the distribution and storage. And if we do not have time for questions, I promise I will take some in the second part of the portfolio presentation. Dionisis, please.
Thank you, Mirela, for the introduction. Good morning, everyone, from my side as well. I'll try to be super quick, as I know I'm eating out of your coffee break. So I'll be guiding you through the portfolio of projects that we have on hydrogen storage and distribution. And I will try to go as quickly as possible. Tomorrow we have a parallel session on this topic, so if you're interested to hear from the 4 projects that we'll be presenting at 11:45, please join us there. As this is a new kind of a pillar, I would just like to go through a quick overview of what we have in terms of activities under this pillar. We've heard a lot about the massive amount of renewable hydrogen that we will have to produce in the coming years. And this also means that we also have to scale up our capacities in distributing and storing the renewable hydrogen. Starting with storage, in our program we're looking at large-scale storage, both underground and above ground. Underground, we're looking at both salt caverns and porous media, looking at depleted gas fields and aquifers. And then on the distribution side, we're looking at really a lot of options, because there is clearly no silver bullet, no clearly winning solution. And starting with pipelines, we're looking at both at facilitating the repurposing of pipelines to 100% hydrogen, but also looking at blending and how that can impact the grid and its components. Then on to compression and purifications, which are essential elements in the distribution chain. We're looking at improving their availability, their costs, etc. And then on to the rest of the transport means, where we're looking at all possible options in liquid carriers, ammonia, liquid organic hydrogen carriers, gaseous tube trailers, improving their density and storage capacity, and also improving the supply chain on liquid H2, which we haven't touched upon at all in the previous program. So we're really trying to scale up our efforts in improving the supply chain on liquid H2. Yeah, and I would like to show you a few of our projects on this topic. Starting with underground storage, we have Project Hipster that is looking at underground storage of hydrogen in a salt cavern. Now this has been demonstrated before, but in this specific project, we're looking at cycling the pressure in the cavity, and this is done. In this case, we're not adding or removing hydrogen in order to adjust the pressure. The amount of hydrogen remains the same, but we introduce and remove additional brine in the cavity to increase and decrease the pressure of hydrogen. And you can see on the top right the cycling program that is planned by the project. The hydrogen will be delivered on site, produced on site through an electrolyzer, and it will be removed at the end of the project, where we'll be also investigating the effects that the pressure cycling had on its quality. Staying on underground storage, we have 2 more projects that are dealing this time on porous media. And here we're dealing with a lower TRL level. We're looking at lab experiments, desk research, looking at mapping possible sites and ranking them in terms of their suitability and techno-economic viability. And you can see on the right there's a small map already delivered by the project, which is showing the possible sites in Europe for porous media storage sites. And another key deliverable will be a ranking of possible sites and some case studies that will be developed further. Staying on the storage aspect and going into above ground storage, in our program we have mostly looked at innovative storage solutions such as metal hydrates. We have 4 projects on this, and the pinnacle of these projects is Project HiCare, which is approaching its end. It's looking at storing hydrogen in a metal hydrate coupled to a phase-changing material. You can see it in the picture in the center. The system has already been designed and constructed and will be commissioned soon. So you can see on the top the metal hydrates, and on the bottom is a phase-change material that will store and release heat to improve the overall efficiency of the system. And moving on to the distribution side of things, looking at what we're doing on hydrogen injection in the natural gas grid. Here we have one main project, Higgs, which was funded towards the end of the last framework program. And we're looking at, they're trying to build a testing, they have built already a testing platform to look at the effects that different blends have on the materials in the natural gas grid at the high pressure network. And we will have 2 more small-scale demonstrations as part of the 2 valleys that we have, Green Highland in Mallorca and Heaven, where we'll be injecting small amounts of hydrogen into the grid. And it is a topic that we will be further investigating in the future as part of our program. We have 2 calls, 2 topics in our calls, one on the compatibility of non-steel materials in the gas grid, and another on developing a sensor for leak detection. Yeah, and since we have blended hydrogen, we're also looking at possibilities to separate hydrogen from the natural gas grid. Here we have 2 projects, High Grid and Memphis. The 2 of them are dealing with different concentrations of hydrogen in the mixture. Yeah, we have achieved already good targets and good results in terms of energy consumption for both the separation and purification parts. But these have not been combined with high hydrogen recovery rates. So this is the next target to maximize hydrogen recovery rates together with low energy consumption. And on to compression, which is a key part of the distribution chain. It is very important. It is almost like a football player, the star football player of the team that is most of the time is injured. And this is what we're trying to solve. We have indications that 40% of the downtime in a hydrogen refueling station is due to a failure of the compression. So in our projects, we're trying to improve availability, efficiency, and the capex of the compressor. We have a series of projects called Cosmic, where we're looking at a hybrid compressor, a containerized solution, where the low pressure part of the compression is taken care of by the metal hydrate solution, and then the high pressure range is taken care of by the mechanical compressor. And we can see already some good results in terms of the absorption capacity that has been improved for the metal hydrate part, and the reduction of capex for the mechanical compression, along with the increased flow rates. And the idea is to have it tested in a fully real-life environment in order to refuel 2 tons per day of hydrogen. So yeah, then on to hydrogen carriers. Here we've had already 2 projects on liquid or organic hydrogen carriers. This solution is very promising according to several studies for very large transportation distances. And yeah, this is one of the reasons that we're looking at it. We have already had a proof of concept with Project Highstock, and you can see the 2 pictures on the left. One is for the storage unit where we bond the hydrogen into the liquid, and the other is for the release where we remove hydrogen at the end-use site. And it has already been demonstrated for 2,000 hours of testing, showing good results in terms of purity of hydrogen. And we will continue to support this in our call. We have 2 topics in the call that is closed now, one for liquid organic hydrogen carriers and another for ammonia. Yeah, and finally, as I mentioned, there are several modes of transport of hydrogen available, each with their own merits and disadvantages, and we're looking into most of them. Even though we have already commercially available gas tube trailer solutions, we're trying to increase their pressure range to improve their capacity, reduce the amount of trips necessary to refuel stations, and reduce overall the cost of hydrogen delivered. And then, as I mentioned, for the first time in our program, we're really looking into liquid hydrogen infrastructure, where we're looking into, first of all, developing a large-scale tank solution for the shipment of hydrogen through the maritime sector. And our overall targets there is to go to sizes of up to 350 tons and keep the boil-off rate rather low to 0.5% per day. And this will be tested in a downscale prototype of 10 tons as part of the project. And in order to produce the hydrogen necessary for all this, we're also having a topic on improving hydrogen liquefaction, improving the energy consumption of the process and overall the cost. Yeah, and in summary, some key points to take with you. As you've seen, we've had several projects on underground storage. They're gaining a prominent role in the partnership, and the first demonstrations are starting now. We have on the distribution side, small-scale demonstration on hydrogen injection in the gas grid already taking place, and we'll be looking further into the compatibility and repurposing to 100% H2. On the compression side, we have innovative solutions scaling up, and the next step, of course, is to test them in real-life conditions. And on hydrogen carriers, we had the first proof of concept on liquid or organic hydrogen carriers, and our next priority is to also step up the infrastructure on liquid H2. I would like to thank you very much for the attention. Very sorry for taking into your coffee break. I hope you'll still have some time to enjoy. Yeah, thank you very much.
Thank you very much to both of you, and it was not your fault, my fault, that I took the time of the coffee break. So just to say that now we were supposed to take half an hour break. We eat from it about half of even more than it. There is coffee break, of course, 1 floor down. So not on this floor, you go into a restaurant 1 floor down, where is the coffee break. And let's try to get back in 15 minutes max, because we still try to make it, and many still presentation to make. So waiting for you in 15 minutes. Sorry, stay with me, because I try to make questions. Anyway, we have nothing for slides. So we'll try to he's here, but he's not in the room anymore. Claudio. It's here. Claudio, the lady would like to know more about the panel on sustainability and circularity. Okay? Yeah, go to the coffee. Okay. Welcome back. I would like to restart. I know people are still coming into the room, and I hope you had a nice break, networking. We promise, at least the lunch will have more time for you to network. Yeah, we also have a lot to share with you, as you can see. We try to be as short as possible, but yeah, it's a challenge. Good. Just to remind everybody that we have the Slido, like we had also in the days before. Please use Slido if you have any questions, in particular people at home, because for the people in the room, we will give the possibility to also put questions live. Please use Slido, and if possible, and if we have the time, we will try to answer to them. Good. So, I would like to continue with the second part of the morning, general presentations of the program portfolio. And you heard in the first part from the production and from the distribution and storage. Let's go into the end uses. And for that, I would like to invite to come on the scene Lionel Boillot, project officer on the transport side, and Antonio Aguilo, project officer on the heat and power, clean heat and power side, but also the team leader of the project officers, Antonio. And for the cross-cutting issues, Alberto Garcia. And I'm very pleased to have them. And I promised to the other two, to Nikos and Dionisis, they will join us at the end for the questions, okay? So, thank you very much. And without taking, again, myself too much of the time, I will give the floor to Lionel. Lionel.
Thank you very much, Mirela. Dear colleagues, dear ladies and gentlemen, good morning from my side. I'm project officer in this transport portfolio. I will give you a snapshot of the most recent activity in this area. But the indirect impact of our funding, Mirela indicated 440 million euro of funding over the past 10 years and a bit more, is to be witnessed at the exhibition hall. For example, keep in mind, to have trucks 2 years, 3 years ago, it was nowhere on the landscape, a crazy idea. And today you could see 2 of them from different OEM just down there, two floors down. So it's a bit of contribution, indirect, from the Clean Hydrogen JU partnership. I will give you this short overview. And it's an honor to be in front of you. There are 3 other colleagues who grandly contributed to the preparation of the slide. Pietro Caloprisco, Claudio Pavel, and Luca Feola, and I thank them for their contribution. The overview is complemented as well by a specific session. One will take place later this afternoon on manufacturing, 2 of them tomorrow on the end-use transport and on the building blocks. The area, if you want, is divided in 2 streams. First stream is the transport mode, so the cars, the buses, the ships, and so on. And the other streams are the building blocks, the fuel cells, the hydrogen tanks, everything that supports the different transport modes. So, well, my presentation will follow these 2 streams, and I'll be starting with the different transport modes. So, quickly, if you have just a few seconds of attention before leaving, on the early project of cars and buses, the fleets of vehicles are in operation, collecting data and providing their showcase, their business plan sometimes. For most recent application, speaking of trucks, trains, maritime as well, and a bit of aeronautics, the equipment, fuel cell, hydrogen storage, have been developed, specifications have been made. Sometimes the equipment has been integrated on board the vehicle, and for the trucks and for the train, test on board the vehicle is ongoing. Let's go into the detail. Cars. Out of the 1,800 cars funded by the JUs, 1,700 of them are already in operation, accumulating the kilometers, more than 1 million of hours driven on board this vehicle. And in fact, the viability of the business case for the fleets, and especially taxi fleets, has been confirmed. We are now reaching new cities. Copenhagen now has a fleet of more than 100 taxis using hydrogen. And in fact, the key factor of success was there the combined deployment of the infrastructure for hydrogen and the vehicle on the other side. So you kill the chicken and egg problem. What we see as a new business plan as well is when independent taxi drivers would, against a monthly lease, get a package that includes the hydrogen cars, access to the refueling station, the access to the hydrogen, obviously, and access to an app that allows for booking the different taxi rides. Two projects, H2ME2 and Zephyr, have been publishing quite a lot of information, quantitative and qualitative data, that I encourage you to have a look at. I move now to the buses. About 250 buses are now in operation in the roads, within fleet between 5 and 50 buses at each site or city in 6 different countries. And I encourage you to test one. There is one bus down there doing trips from the expo site up until the airport. Go on board or chat with the bus driver to get familiar with the solution. We do have on-the-field data. Range is similar to the one of a diesel bus, 350 kilometers. Good surprises on the consumption, something between 6 and 7 kilograms of hydrogen per 100 kilometer. It's a nice surprise, very efficient fuel efficiency. And every month, about 500,000 of kilometers is driven by the different buses. We will increase the market, both on the type of the vehicle, so 18 meters articulated buses, as well as coaches for the long distance travels. But as well, increase of the market, reaching out new geographies in central and eastern part of Europe, and a dedicated bus roadshow will take place at the end of this year, beginning of the next one, in these geographies. The Zero Emission Bus Conference will take place in October 2023 in Brussels, in the framework of the bus world. So we are no longer, let's say, the OVNI or the ET on the bus planet. We are now clearly integrated in large events such as Bus World. That's an achievement. One example, the project Jive, and I encourage you to have a look at, there are some leaflets on the table in the back, and you could have access to more information there. And the project Jive is now designing success stories or reporting to the citizens the benefits of these hydrogen buses. They started with the city of Pau. Pau is in France, in the south. They have deployed 8 hydrogen buses, long one, 24 meters. They are quite specific. And these buses are used for a high service network. So that means they are linking the main train station with the main hospital, combining with the main area of activity in the city. They are in use all the time. More than 4 million trips have been traveled. More than 1,000 tons of CO2 has been saved. More than 400 liters of diesel has not been consumed. This is great achievement. But we noticed that the bus is not a way to move passengers from one side to the other. It can act as a springboard for larger hydrogen ecosystem or hydrogen valleys within the city. It brings new attractivity into the cities. It brings high level and skills jobs for the production of the hydrogen, the maintenance of the HRSs, maintenance of the buses, things like this. And it renews the vigor of the use of public transport in a post-COVID-19 climate, if you want. And if I can give a quote as well, it's a developed country is not a place where poor people have cars, but on the contrary, it's where the rich people use public transport. So hydrogen transport can help this transition. I move now to trucks. 2 projects. Revive, and H2O. Each of them to deploy between 10 and 15 of these trucks. For the Revive project, 4 of the trucks are on the road in the Netherlands collecting garbage in silence mode, limited vibration, for the pleasure of the citizen that do not have to be waken up early in the morning by the garbage truck. 7 of other trucks are in the construction, in the making, in the workshops. There will be a detailed presentation of Revive tomorrow in the morning. And the H2O project has now deployed 2 prototypes from 2 different OEM. So it's the Iveco and the VDL. The aim is to have a long haul distance, so 600 kilometers at least of autonomy for these trucks. These were our objective from the past, if you want. Now with the Clean Hydrogen JU, would like to multiply by 10 the ambitions. Instead of 10, 15 buses, to have 150 buses, trucks. 150 of these trucks on the European roads. We have a project which is in signature process and hopefully will start beginning of next year. It is a project that linked the Clean Hydrogen JU with CINEA, an executive agency that will support the infrastructure, the hydrogen infrastructure, to make corridors of the hydrogen. I move now to the maritime. Let's change the atmosphere. Let's sail a bit. A sector that has increased quite fast over the time and getting bigger and bigger. Look at the upper part for the maritime. We went from 0.15 or 16 megawatts in a small vessel to up to fuel cells of 3 megawatts. And because there is no one-size-fits-all, there are different needs of power, of autonomy of these ships. Therefore, we've been looking at different types of fuel cells, SOFC as well as PEM, and different types of fuels. Hydrogen, be it gaseous or liquid, and as well as ammonia. Unfortunately, today, there are no regulation, no rules that tell you if you like to do a hydrogen ship, this is the way to do it. So all these ships have to go through an alternative design process, which is lengthy, it costs more money, and is subject to interpretation. Therefore, we do have the project E-Ships looking at pre-normative research, helping the International Maritime Organization to develop guidelines for the use of hydrogen as a maritime fuel. In the fluvial, bottom part of the graph, there the idea is, the ambition is not on the power of the fuel cell, but it's to develop a fluvial corridor for use of barges. These ships, at some point, they will have 2 stops. They stop at a port. In the port, they still have to operate. And in order to provide clean operation, there are 3 fuel cells used in a stationary manner to provide heat and electricity in the port of Palma, Orkney, and Tenerife, as well in Valencia. 3 equipment to handle containers, to load and unload the container ships, will be deployed early 2023. So it's a yard tractor and a reach stacker in the port of Valencia. This is for the hardware. Then on the software, if you want, we have a study looking at the importance of ports in a hydrogen economy, where hydrogen will be imported from other continents to Europe. What is the demand for this hydrogen at different times of horizon, 2030, 2040, 2050, and how to match this demand with the supply. The side objective as well of this study is to generate a community. So there is a network of hydrogen European ports. Trains. One project, FCH2 rail. Goal is very simple. It's B-mode fuel cell running together with the battery pack. Both specification on the battery and the fuel cell has been made, tested on bench, integrated on board the locomotive, and now the locomotive is on the rail being tested in Portugal and in Spain. The other activity of this project is to look at homologation and identify normative gaps. Let's move into the air. 3 projects of small scale, let's be honest. We started in 2012 with an auxiliary power unit for the kitchenette of a small aircraft, then moving towards emergency system, a ram turbine within a small aircraft. And then in 2018, it's the project Heaven, which aim at doing a flying demo with liquid hydrogen. So development of liquid hydrogen tanks, and then you have the regular fuel cell, PEM fuel cell. Aeronautic is the crucial sector in Europe. We do have leadership. This leadership must be kept. In synergy with Clean Aviation JU, the ambition is to have flight demo as early as 2030. This is why, in a new phase from the call of proposal 2022, we have launched topic on how to increase the size of the fuel cells from kilowatts to megawatts, and include as well new generation of fuel cell for the aeronautics. That's it for the different transport mode. Now I move into the building blocks. So on the fuel cell stacks, the component, the balance of plant will continue the support. It's needed for the different transport mode. Manufacturing integration of the sustainability aspect. For the hydrogen tanks, how to optimize the space by using serpentine, if you want, of conformable tanks. And for the infrastructure, it's improving the efficiency of the delivery, because now it's a network of HRSs that need to be monitored and managed. I go low TRL, MEAs, excellent progress, technical progress has been made by the project Gaia. They were the winner of the success stories. 1.8 watt per square centimeter. This is beyond state of the art from a certain OEM. The platinum loading 0.25 gram per kilowatt. It's still 2 times the ambition that we should achieve by 2030, 0.125 gram per kilowatt, but getting there. And all this has been developed for the light duty vehicle, for cars. Now the shift goes toward the trucks, the heavy duty, where the key matter is to increase the durability and the power density of these MEAs as well as the stacks. This is the core of 2 projects, Immortal and More Life, and it will be continued by a new project starting from January 2023. Still on the modules of these stacks, an interesting project called Stash. Stash is defining 3 sizes, if you want, of modules. The dimension of these modules have been defined. The interface of these modules have been defined, so pneumatic, electric, fluidics have been defined, and the software behind has been defined. They are standard. There are 3 types of box, if you want. Why? It's because it's as a plug-and-play box, you could be able to fit it on board a truck, a train, a ship, a plane, or whatever. That's the goal of Stash. Some of the modules have been built and are now being tested, and exploitation workshops and so on are public. Manufacturing, the challenge remains to reduce the cost, and to reduce the cost, bring the economy of scale, bring the volumes. 3 streams of project. One looking at the manufacturing line, how to reduce the scrap, how to increase the quality of the product, the design for manufacturability, how to make it easy from start, and the production of MEAs in large quantities. Hydrogen storage on board. The issue there are very simple. The geography of a usual tank is not ideal. It takes a lot of space. So how to improve this? By using conformable tanks. The project at the bottom, shaped. The material is costing quite a lot. Carbon fiber plus is not available in Europe, so we need to replace it. That's the core subject of Project Thor. and to reduce the cost. These tanks are still expensive. How can we produce them better, faster, cheaper? That's the objective of TAIA. Next phase, for the aeronautics, very specific, the tanks of liquid hydrogen that are lightweight and can fly in the air. Hydrogen refueling station, this will be my closing chapter if you want. From this shift, going from automotive to the heavy duty for the trucks. Today, standard exists, SAEG 2601, to refuel your car with a 5 kilogram of hydrogen in 5 minutes, more or less. But if you apply the same flow, same speed for the trucks that have tanks of 80 or 100 kilogram of hydrogen, it will last quite a long time. So we need to define new standards in order to speed up that refueling. Well, this is what the project Pride has been looking at, to improve, depending on the technology on board a truck and the technology within a HRS, how to optimize that and not do a refuel at the default speed. Experience, feedback from HRSs that are in use, in Paris for the fleets, for example. Look at the graph on the right-hand side, how it has shifted from 2019, the first 8 months, January to August 2019, up until now. The number of time an HRS is delivering per day, more than 200 kilogram, has significantly increased. So for the HRS owner, operator, it's a full business, a fleet, a network of HRS to manage, to do delivery in city centers. This is where the taxis are usually. And you need to match the functioning of the HRS with the expectation of the taxi drivers. So how it will pay, you cannot say, no, my station is broken. I'm now reaching my conclusion. On the early project for the buses and for the cars, we do collect the data and get interesting feedback, reaching out new markets. For the trucks, everything is there. We paved the way for this truck arrival on the building blocks, on the infrastructure, and on the testing of the trucks themselves. For the heavy machinery, heavy duty, again, we are preparing the different market, trying what could work. For the R&D, continuous support on the building blocks, increasing the power density and the durability of the PEM fuel cell. Thank you very much.
Thank you. Thank you very much, Lionel, for this very interesting presentation. As you can see, it's a challenge for us to distill for you all the activities we do, and to try to make them in 15 minutes is really a challenge. And for that reason, I don't put any more pressure. So thank you. I see we're getting questions in Slido. Please send them in. Please continue to send them in. I think to one of them, Lionel meanwhile answered. And to the first one, just to quickly answer, yeah, combustion engines for transport are not in our scope. I mentioned this morning what is in our scope. Please refer to our 3R again, Strategic Research and Innovation Agenda. Of course, there are combustion engines for transport using hydrogen, but this is not in our scope. Again, we work on fuel cell using hydrogen for transportation, and that is probably addressed by other parts of the Horizon Europe program or other programs, such as, for example, the 2.0 partnership. I hope I answered to that question too. Good. So, next speaker, Antonio, the floor is yours to present to us the portfolio of projects and, again, achievements on the clean heat and power. Antonio.
Thank you. Thank you so much, and good morning, everyone. It's great, as my colleagues have said, to see people in person after so many years. It's very good. So we've heard about transport now, so now we are going to hear what can we and what are the progresses on when it becomes using hydrogen for heat and power applications. I want to thank to Eleni, my colleague Eleni, which has also contributed to put this slide together, so thank you for that. And this afternoon, after lunch, she will manage or moderate a session looking at a number of the projects that I will today briefly summarize. Last year, I was looking back quite a bit, no, when I was starting this presentation, so I thought it still is good to do that, but I would also like to hint a bit of what we are going to be doing in the next framework. No? We have, if you want, started activities at the very beginning of the first year undertaking. I think, if I'm correct, the activities actually of the first year undertaking were focusing a lot on applications and use transport and use heat and power, looking at fuel cells. So we have really, and I think here the efforts of industry and research working together, early stages of research activities, looking at component development, materials, but then looking at better ways that we could manufacture systems, led to a number of proof of concepts and early trials, if you want. We were already starting early trials in real installations. Of course, not everything worked, but that helped very much because we went back all the way to the very beginning, if you want, or not to the beginning, but we went back to research activities that helped to improve the products. And we then launched the second round of trials, demonstrations, with this second generation of products. And I think it's fair to say that this has happened throughout the whole range of applications, domestic heat and power, commercial service sector applications, but also large-scale applications for industry. Now, looking forward, there are a number of things we still have to do. As you will see later on, there is great performances that have been achieved. Probably we still need more volumes. We can do something more even through mass manufacturing to reduce the costs, and that we will look at that in the next framework of the partnership, looking at how we can improve fuel flexibility, but we are opening our support to gas turbines, burners, furnaces, boilers as well. Especially for the turbines, it's important. We will have more and more renewables. We need to be able as well to decarbonize the peak power generation, quick response that now are done by gas turbines, so we want to transform them and allow them to run in hydrogen as well. So I'm going to cover now the different sectors where we are with things. Domestic heat and power, I'm talking here about fuel cells using for domestic applications, different type of approaches. Again, we have different type of players. Established heating OEMs are developing and have developed their products. Also SMEs, we have supported them to also put products in the market. And the market is growing. I mean, we have contributed to develop, as said, this first generation. We are now trial the second generation, and these products are available off the shelf. You can go, you can order, and you can install one of these systems in your homes. And very important as well, the support that has been given or is being given in Germany, which has helped to create then also much larger numbers of units installed. In our project PACE, which is still ongoing, we are targeting close to 3,000 units. We have seen 2,300 units installed, but the KfW 433 scheme in Germany is helping and has developed the market now to the order of 20,000 units in Germany. So we have a lot of data, we have a lot of experiences gathered, more than 26 million hours of operation we have gathered in our projects. We have units installed throughout Europe. It's very important that in the early phases, the space project allowed the manufacturers to have the confidence to go and to develop manufacturing processes to allow for volume manufacturing, and now a number of the OEMs are able to produce more than 2,000 units per year. And we were talking about, okay, when we will see if these durabilities of the stacks, for instance, are being met. Well, I think now we can say that because we have units that have run in the field for more than 40,000 hours. So we can now with confidence say that targets of durability at the stack level have been achieved. Efficiency that was already done several years ago. We have a whole range of technologies, but we see power efficiencies reaching 60% operational data here. And then, yes, we may still need to do some work on the CapEx, but CapEx have decreased considerably. And this is why we will continue in the Clean Hydrogen Partnership to support activities aiming to reduce the cost of the fuel cells, but also important through manufacturing, innovative manufacturing processes. But we still continue working on the next generation. We have heard yesterday, we will have a lot of hydrogen produced, we need to use it. But it's not only about hydrogen, it's also about other renewable fuels. So this next generation of products, these projects are working precisely on that, to develop systems that are flexible to the type of fuel that they can use. And we have a number of ongoing projects. We hope to be able to present specific results next year. One of them, looking at solid oxide fuel cells, developing technology that can run in any type of mixtures, whether it's natural gas, biogas, of course, looking ahead and also in hydrogen. Another one which is looking at developing cost-effective technologies to clean the biogas that then is suitable for fuel cells. And then we also have another line of work on a high-temperature fuel cell that will run on methanol. These are small prototypes. These are research projects, but are looking also at applications in the 100 kilowatt once it's scale up. So we are also developing technology that could, for instance, be suitable for maritime applications. We have done a lot of work as well, looking at monitoring and controls. We have supported a great number and a large number of projects, research projects, and now we are glad to see that we have a project that is going to take the tools that have been developed with the aim of improving the lifetimes of systems, and they are being tested on real units in the field. We will continue doing that. It's a very important objective of our current SRIA, to actually work on units that are able to be an important part of the energy transition, in which we will have scenarios with hydrogen, with other hydrogen-rich fuels, and this is what we are going to focus, giving continuity to these activities. Now we move to larger applications. If we look at applications for the commercial buildings, for the service sector, we have, again, similar story, a number of feedback loops, a number of proof of concepts, early trials that now have helped to develop and to have already finalized designs of this next generation of systems. And here we're having a project, the Consus project, which will be presented later on in detail, which is actually looking at installing around, I think 450 kilowatt total capacity, sub-100 kilowatt systems. And as said, we have already the designs finalized, and 9 systems have been installed. Some of them are already starting to provide data, and we have still 10 systems to be installed. We have reached 20 KPIs in the efficiencies. You can see that here we have stack durabilities that are only increasing. Good availability, which is key, especially if you are an end user wanting to use this technology. Again, we need a bit more to do on the cost. We will provide support to that in the current joint undertaking. And also, when we talk about hydrogen tolerance, we have units that now are able to cope with 100% of hydrogen in methane, in gas, and we hope to see those units as well allowing to take more of that. Very nice project that relatively started a year ago. High power density solid oxide fuel cells for a very specific application in data center. So we hope to have results soon, but this is also a niche application or not so niche that we will be supporting. And as we will have more and more renewable energy, I think it's important to be able to take advantage of the versatility that solid oxide cells can offer. In here, we're talking about a scenario with renewable gases. We are talking about a scenario with renewable energy, power, electricity. So we have started to support the CH2P project, which is looking at polygeneration, taking natural gas, biogas, and producing of heat, power, but also hydrogen. This project has ended. The concept has been demonstrated, probably not at the scale that was intended, but it has been producing hydrogen using the technology developed and reaching over a 600 hours test efficiency degradations of 0.26. So great achievements, especially as reversible operation was tested. Now, all these activities are continued in the Switch project, which is actually developing what we call a reversible trigeneration. So it will be able to take gas, natural gas, but we're now looking ahead at renewable gases. It will be able to produce hydrogen. It will be able to produce heat and power on that mode, but then it will be able also to operate in reversible mode, taking the electricity and to produce hydrogen. These activities will continue. In the OP22, we actually have a project that will look also at the energy grid integration of those systems by looking at how they can be also integrated directly into the gas and electrical grids. We have also under the stationary a number of projects, or one project right now that is looking at power-to-power applications. It's mainly looking at isolated microgrids or grid remote areas, and we have 3 demonstrations. 2 of them are in operation. They are around the 100 kilowatt scale, but they are basically able to provide off-grid communities with all their needs, with energy independency, with robust systems, and basically here we have one system in Greece and one in Norway that have been already commissioned. The one in Greece, it's been operating for around 200 hours, and you can see here the targets that have been achieved for the KPIs that we have achieved so far. There is another one in Gran Canaria, which will be commissioned hopefully soon, which is to provide a milk factory as well. So this is already now bringing, again, production, storage, and end use all within one project. And we are happy to see, because then, of course, we have the scaling up, which leads to the wider applications, if you are, of this power-to-power, also applicable to the hydrogen valleys at a much larger scale. Great project as well, looking at portable generation with hydrogen. This is the Everywhere project. We have, or the project has developed an approach where two containers are used. One of them has the hydrogen bundles, the other one has the fuel cell and all the balance of plant and management system that is needed. We are seeing already two gensets completed, one of 100 kilowatt, another one of 25 kilowatt. Two of additional gensets should be delivered early on 2023, and the campaign for demonstrating this technology has started. The project has seen a period of demonstration in a construction site. You can see that in the blue bottom of this slide, with an effective operation of 67 days over a period of 86 site working days. 500 hours of operations. There have been close to 1,000 kilowatt hour of electricity produced, and you have here the kilograms of hydrogen consumed. The genset was then moved, that was in Spain, in the north of Spain. It was moved to Aragon, and it was part of the MotoGP competition in Aragon, and now it's on the way. I was told actually very recently that it's already there in Tenerife for cold ironing purposes. That will also be tested in there. The smaller genset, 25 kilowatts, it's also being developed, and demonstration activities are currently ongoing. We have another project looking at the applications of solid oxide fuel cells for remote applications. That's looking also at sub-kilowatt systems, which then can be combined to offer larger capacities. We are targeting 49, 50 units in this project. 30 systems have been commissioned, and I think we can already say that of the systems that have been in operation, they have been demonstrated to operate suitably in harsh condition, less than 40 degrees Celsius. And that was one of the main objectives of the project, is to develop that technology able to operate in those conditions. Very importantly, the maintenance, a lot of the times very remote locations where you cannot afford to have high maintenance on those. And through these early units that have been deployed, we have maintenance frequency that was targeted in the project of 15 months, which have been achieved. And finally, the last application is about the use of hydrogen in industry to produce power. Of course, there is the possibility to also recover the heat. And already many years ago, we installed a 2 megawatt system in China. That was really the very first generation of this system, and this is another example of that feedback loop I mentioned before. The unit was run, there were experiences, there were things that, of course, couldn't be in a different manner. So some years ago, we started to support the next generation of systems applicable to the megawatt above scale for industrial purposes. We did it through the research projects that has developed a 100 kilowatt prototype. The project has ended already, and you will hear the details later on. We have achieved on efficiency, CapEx, and stack durability, if you look at the projections of that prototype, the targets of 2024, and the project has been working at all levels. MEA development, so there has been advancements at that level with 80% reduction on the platinum content on the MEA, and very important, the efforts that the project has put in designing those MEAs for high volume manufacturing. A lot of work on designing a next generation of a stack, larger cell area. The 27 kilowatt single stack design has been completed, and it's estimated that at mass production, the cost of this stack could be around 400, 450 euros per kilowatt. And also recently, we found out, and you will hear later on if you follow the session, that there is already plans for industrialization of the technology, and it's great because the project, again, designed for manufacturing-ready technology, and now they can take it to the next step, industrialize, and that's why I believe that those targets are achievable. And at the end of the day, the plan was finalized, factory assembly testing was done, and then it proved efficiencies both at full load operation but also at partial load operation, down all the way to 20%. So my last slide, some conclusions. I mean, we will and we have continued, I believe, successfully through the efforts, as I mentioned before, of this collaboration between the research community and industry, bringing products to the market. long-term of operation of units now at the domestic scale have proven what the manufacturers have been basically rating their units for. We are also now starting to get those units into the commercial building application. We are already seeing how European technology actually also within our projects is exporting that technology abroad, not only at the commercial systems, but also for this remote power application that I was mentioning. And the reversible operation of solid oxide cells has been tested. We really hope that throughout the partnership now we can see those systems scale up as well to the 100 kilowatt up systems being part of the decentralized energy landscape that we will have to also see. And then looking ahead in the period 21-27, as I said, we have extended the support to gas turbines, able to run to 0 to 100 hydrogen in the gas grid, supplying these peak power needs that we will need to have in an energy system with a lot of renewables. And of course, the tricky here is maybe not so much do better than gas turbines, but to be able to do what they do with 100% or with this mix that I mentioned. So it's about keeping emissions to the same levels, keeping the high efficiency and allow for flexible operation. So that's looking ahead, and we already have a project starting on that this year. That's all on my side. Thank you so much to everyone.
Thank you very much, Antonio. Really appreciate it. I know we are not catching up with the time. I'm very aware of that, but as I said, I don't think I can do better than this, because like I also said, we have a lot to share with you. I hope you will stay with us. So last presentation from this morning, Alberto Garcia, Project Officer on Cross-Cutting. Alberto.
Thank you, Mirela. And as you said, this is the last presentation of today or this morning. And as I'm the one between you and your lunch, I try to make it as long as needed and as short as possible. First, let me see how it goes. There we go. Yes, first I would like to invite you and remind you that we will be holding a parallel session on pre-innovative research for standards this afternoon. 4 projects will be presenting, which I think they form a very good representative sample of the type of projects and the impact these projects are bringing to the sector. Secondly, I would like to stress that cross-cutting issues is not new. We've been supporting cross-cutting issues, activities in cross-cutting issues almost from the beginning. And in the previous pillars, you have seen that there are many challenges that we are addressing from the technological point of view. However, mass market commercialization also requires to address some challenges from the systemic or the horizontal nature to really kickstart a hydrogen economy at a significant scale throughout the EU. Previously was the third research area within the program. Within the Clean Hydrogen Partnership is one of the 4 horizontal areas in which we will continue supporting grants and research and innovation activities in these areas. We will indeed continue in supporting activities in 3 main lines. In one, sustainability and circularity aspects. The second one on education and public awareness, and the third one on safety, pre-innovative research, and regulation codes and standards. All these activities will be mainly conducted through grants, through projects, with the strong links with other activities, as Mirela presented this morning, other activities that are running within the project, within the program, like the collaboration with the Joint Research Center, the regulation codes and standards, strategy coordination, the safety panel, and the sustainability and circularity safety panel that we are going to set up very soon. So far, we have been supporting 46 projects with a total funding of 65 million and involving more than 70 countries within all these projects. So let's have a look in the first area, in sustainability and circularity. We are we have supported so far 6 projects with a funding of almost 6 million and involving 10 projects and 10 countries. And in this sense, of course, the technology needs to be, we have to reduce the cost, we have to improve the performance, but we also have to ensure that they are environmentally friendly and they are sustainable and circular. We have been supporting projects like FC High Guide, developing life cycle assessment guidelines to provide guidelines on how to assess the environmental impacts of these technologies. We have supported projects like high-tech cycling as a first step developing recycling and dismantling procedures for these technologies. And of course, the certified project, everything started as a project within Crosscutting. Now it continues in its first days, in which it was a pioneer at that time, and it was the first attempt to really shed some light and provide truly information on the origin of hydrogen. When we say it's renewable hydrogen, we know it's renewable because there is a robust scheme behind. Currently, we are supporting 3 projects. One is the SHIP project, which is at some point updating the guidelines developed by the FC High Guide projects about the environmental aspects, but also they are including the social and economic aspects, so we can tackle the 3 aspects on sustainability, let's say. We are supporting the EGOS project, which is as well a pioneer, is the first milestone to develop eco-design guidelines for these technologies, in particularly on PEM fuel cells and solid oxide technologies, and I'm pretty sure that it will be followed by others addressing other technologies. And also we are supporting the Best for High, building on the results of high-tech cycling in order to develop and test novel and existing technologies for recycling both solid oxide, fuel cells and electrolyzers. Besides the activities within the project, we have different other activities. Thanks to the cooperation with the Joint Research Center, they are helping us to assess how the projects are performing in terms of environmental aspects, but also we have a set of activities, and I would like to highlight one which is related with the European Platform on Life Cycle Assessment, because we are working with the JRC to create a hydrogen node so that all the projects can provide the data sets that they use to perform LCA in this hydrogen node, which will be publicly available, and any practitioner will have the data there for their use. Another thing that we have done this year as well is the expert workshop on environmental impacts of hydrogen, and we did it, I think it was at the beginning of the year, with the support of the Commission, Hydrogen Europe, Hydrogen Euro Research, the US Department of Energy, Hydrogen Council, and IPHE. And in this 2 days workshop, we gather a better understanding and knowledge on what is the real impact of hydrogen in the global warming, what is the real impact of hydrogen in hydrogen releases in the environment. No? The workshop has led a publication. The JRC has published a report. You can find the link within the slide, and soon we will also publish the PowerPoints displayed during the workshop. Very interesting topic. I would like to draw your attention on this. The second area is on education and public awareness, and here we have been supporting 15 projects for for about 18 million euros involving 18 countries. And all these projects, they have been developing educational and training programs, tailoring it for different target groups, from young professionals, technicians, safety officials, first responders. Also, we have created an e-platform for connecting all this knowledge through the NetTools project. And also through the Teach project, we are building a European network of universities. All these projects together, they are addressing different levels of education, from undergraduate, graduate, postgraduate, but also different types of education, vocational and or mandatory or formal education, let's say. Different learning formats, from e-learning or blended, passing through different features like virtual reality or mock-up installations, to name but a few. Now we have 2 projects running. One is the Teach project that I mentioned, that it's developing a master course, a full program of master course on hydrogen fuel cells technology that can be used as a standalone teaching material, but also can be used to complement the teaching that is being given in other universities. A very interesting approach with this blended approach. And the other project is High Responder, which builds in a successful project, High Response. And here we are supporting the development of a training program, let's say, to make sure that all the learning from the High Response project are spread throughout Europe. And when we have an incident, an accident, our first responders in Europe are ready and prepared to know what to do. On the left hand and on the right hand side, you can see a little bit the breakdown of the countries and the geographical coverage. And since 2016, which is where we started to gather data, we have been able to confirm that more than 4,500 students or trainees have been involved in these projects from more than 15 countries, and the teaching have been given in more than 12 languages. Also in the graph at the bottom, you can see the breakdown between primary and secondary education, higher education, meaning university and vocational or professional training. Also very relevant, although Mirela mentioned it this morning, the observatory, we have a specific module or specific chapter within the observatory on education and training with more than 300 trainings on hydrogen fuel cells publicly available. Please have a look. You can search through the different level of education, but also the course of the focus of the course, the languages, a very useful tool in case you want to learn and increase your knowledge on hydrogen fuel cells. Safety, preventive research and regulation codes and standards is the area in which we have given the majority of the support. We have supported 26 projects with a total funding of more than 45 million and involving more than 21 countries. I guess that on safety there is no need to say that to really make a success of this technology and to have a mass commercialization, technologies must be safely designed, safely used, safely deployed, and safety is of paramount importance within the program. We've been supporting projects or research and innovation activities addressing key safety aspects, like for example, H2Sense project addressing hydrogen sensors, Susanna building what they call the hydrogen model evaluation protocol in order to validate and verify the results of CFD models for safety analysis, and also H2Trust project, which was the first attempt to create an expert group on safety, which was followed by the European Hydrogen Safety Panel. Besides the activity within the project, we also have a lot of activities within the program, like thanks to the cooperation with the Joint Research Center, we are working with the Hydrogen and Accidents Database 2.0, which is the European Reference Hydrogen Safety Database. We are supporting the development and increasing the number of events and deriving lessons learned thanks to the cooperation as well with the safety panel. We are working with the tools of innovation monitoring team in order to build a research space on hydrogen safety, which could be very useful as well for people involved in this domain. And of course, we are all together cooperating and supporting the European Hydrogen Safety Panel. In this sense, for those who are not familiar with the Hydrogen Safety Panel, this is a group of experts composed of 15 members, if I'm not mistaken, and they are helping us. They are sort of a safety advisor to the program. They are helping us to ensure that all aspects around hydrogen safety are adequately addressed within the projects, but also at the program level. And also they are contributing or promoting and disseminating a high-level safety culture. The technologies must be safely used, safely deployed, safely designed. In that sense, they work in different working groups, as you can see, and this year they have been reviewing the safety plans of the projects. They have also organized a webinar on safety planning and management, and they are preparing different reports like the safety plan, an update of the safety planning guidance document, an update of the lessons learned from past events from the Hyatt database, and also they are going to release before the year end several reports on CFD models for safety analysis, risk assessment, and engineering on hydrogen safety. We've been supporting on pre-innovative research and regulation codes and standards, plenty of projects indeed on pre-innovative research, because we need to address the knowledge gaps that are still there on regulation for supporting regulation codes and standards. We've been supporting the project like High Law to identify the legal and administrative processes, what are the barriers and how to overcome these barriers, so then the different revisions of the regulation codes and standards address those barriers. And as I mentioned, Certify, it's setting up these guarantees of origin to make sure that when we say renewable hydrogen, it's renewable. The majority of the activities have been given to pre-innovative research activities, and I would like to spend just 1 minute in the graph at the bottom, because I think it's relevant to remind everybody that, of course, regulations are developed by authorities having jurisdiction, and in many cases, these regulations and these codes refer to standards. The standards are developed by the industry in these standardization developing organizations, and somehow they try to represent the best knowledge available at some point in time, and what they somehow reflecting the state of the art. And what pre-innovative research does is to fill the gaps in that knowledge or bring new knowledge to really improve the state of the art that then can be referred into the standards or directly into the regulatory documents. This is an essential step, and being a research and innovation program or implementing a research and innovation program is where we believe we can make the most impact. We are indeed supporting 9-10 projects on pre-innovative research. Some of them, they are addressing aspects related with safety for improving regulatory documents. The Presley project was addressing liquid hydrogen aspects. The High Tunnel project has or is addressing or has just recently finished the safe use of hydrogen vehicles in tunnels or semi-confined spaces like underground parkings. Multi-high fuel project is developing safety practices for dispensers of hydrogen within refilling stations with other fuels, setback distances and so on. The Pride project has developed different refilling protocols for heavy-duty applications. The E-Ships is working on the waterborne applications. We have also projects addressing blends, natural gas and hydrogen blends, like the Taiga project, which is addressing the effects, is improving the knowledge on the effects of these blends in domestic and commercial appliances, or the Higgs project, which is looking at the effects of these blends in the high-pressure natural gas grid. We are also supporting projects focusing on developing stack testing, ID-ASTA for PEM and AD-ASTRA for solid oxide fuel cells. And also we have supported the project Hydrate, which is the continuation of the High Cora project dealing with hydrogen quality. The ones in yellow will be presenting this afternoon, so remind at 4 we will be having this parallel session of innovative research. All these projects, somehow, they are providing information to create and further develop the standards. We are covering the entire hydrogen chain, from the production, storage and distribution to the end users. And of course, it has to be targeted, there has to be an impact, no? And in that sense, almost 50% of the projects running last year were addressing IEC standards, while the rest were addressing ISO and Sensenelec. In this sense, I haven't included in the slide, but I would like to also stress that we are working with the JRC in building or developing these harmonized testing protocols. We have a set of activities, particularly on high temperature electrolysis, and we are developing these harmonized testing protocols with them, and also with Sensenelec. We have different activities. One of them is related with the hydrogen quality for industrial gases. There is a survey ongoing, so I would like to invite you to help Sensenelec in developing the standards and select the purity, the quality of hydrogen that will be used in the next years and from now on in the industrial sites. In that sense, in conclusion, I'm coming, Mirela. In conclusion, sustainability, circularity, awareness, all these are cross-cutting issues that are really essential for the commercialization of these technologies, apart from the technological ones, of course. We are addressing all these challenges through projects, through research and innovation activities, but also through the other activities running in the projects, in order to have a frictionless and, let's say, a smooth transition and a deployment of these technologies. And altogether, we believe that they encompass a comprehensive portfolio of projects and activities that supports not only the program, but also the sector in Europe and beyond. And with this, I think I've finished. Thank you very much for your attention.
Thank you, Alberto. I will take 5 more minutes before we get into the break. And while I invite both Nikos and Dionisis to join us, I would also like to answer a few of the questions that we got on slide, and then give you the possibility in the room to put some questions. So, just quickly, there is a question which we didn't put it in the public domain. Thank you, Luca. Luca is helping me with the questions. However, I want to address it because the question is, why do we have the gas turbines in our program when the industry looks like it's ahead? That's interesting to hear because it's industry who's telling us we should do it. So I'm really surprised, and I'm going to put the question back to the industry then. Or maybe you should address the industry. If you believe we should not do that, fair enough, then we have more money to do other things. I'm just very clear on that. So again, like I said, it's the industry who's telling us we should work on that, because the turbines that we have currently need to be still worked on to be able to work on different admixtures. Yes, Antonio, if you want to compliment me.
And to say,
yes, it works.
To say that there are, and we know, we are aware of projects that are working already in some blends, but what we get from research, also from industry, there is still a need to develop new ways in which you can really keep the efficiencies, keep the NOx emissions, and to develop new ways to go about the use of gas turbines. So yes, it seems initially that there are projects out there able to run on these hydrogen admixes with gas, but there is, again, need to go back to research to develop those systems that will allow to do it with the right NOx, with the right efficiencies, with the right flexible. There I would encourage you to go to the SRIA and, of course, bring us comments if you have, because then there are the KPIs and it's all quite well explained, so we would welcome indeed any feedback that we could have.
Good. Another question I would like to take from the Slido, and then we go, like I said, I promise, in the room. It's for you, Alberto. If hired and team are available, and if not, why not? They are available, but go.
Indeed. Well, I will start with the team. Team is available. You can find it on our website. If you go to the tab on knowledge management, then you will have access to all the research thematics or spaces that we have been working with the JRC, and you will find also the safety, let's say, space there. Hyatt, I'm afraid that it has been offline for the last months. JRC is working on fixing the issue. However, it is offline in any case. If you contact us or you contact the JRC, we can provide you access to the database offline, let's say. However, as I said, we had the JRC had a hijack, they was attacked, and the database has been put offline, and they are working on the database to put it back online. Yes.
Thank you, Alberto. And then a question on Certify, I guess. I'm trying to understand the question. I read it several times. I'm going to read it loud. Is it the point where certification changes from the partnership to the commission? Doesn't look like a question to me, but I'm trying to understand it. And perhaps the GNR, this has gone from a pilot effort to full scale. Maybe you can elaborate how we provide input to the GNR and to the policy.
Okay, so the policy mandate is for all the member states to develop their geo schemes, and this has been set by Red 2 and Article 19, where the Commission instructs that all member states construct their geo schemes on gas and on electricity. And what we are trying to do with Certify is, because we have already done a pilot, we have already designed a scheme, we're trying to share these learnings, what we have learned, with the member states that are already moving ahead and setting up their geo schemes. And that is one aspect that we're dealing with Certify. The other aspect, which is more on certification, is the fact that we are also trying to address the compliance with the targets that are set in the Renewable Energy Directive, the renewable fuels of non-biological origin, if you have heard of them, I'm sure, where we have a 14% target in transport, and there we need a separate type of certification. The GOs will not suffice for this, and we're also trying to set up a voluntary scheme that will help certify these fuels. And that's the second aspect of Certify.
Thank you, Dionisis. Any question in the room? Yeah, there's a question in the back.
Regarding research and innovation activities for the entries of hydrogen, transportation and stationary are stated. How about the industry as a hydrogen feedstock for innovative technologies? Do we consider it in the hydrogen value?
I hope I'm getting well the question. So you are asking about
Hydrogen usage in industry as a feedstock.
Yeah.
No, in the end use scheme,
Yeah.
Transportation and stationary are stated. My question, do we
Yeah.
need to consider the
Yeah.
hydrogen feedstock for the hydrogen values?
Yeah, we do have also such projects, and I think Nikos can already comment on that. They are covered, they are a bit in between, if you want, the pillars of production and uses. Nikos, for refineries, for steel, yeah.
Indeed, some of our large electrolyzer demonstration projects are cases of using hydrogen as a feedstock in industry, light metal industry for surface treatment, refineries, methanol production, and also steel industry. I think you also refer to hydrogen valleys. Did I hear correctly? And if hydrogen is used there, I think that this is indeed the case.
Yeah. It depends on how the valley is constructed. Normally, in a valley, by definition, we ask to have the production and we have to have the use in at least two sectors. And if a sector is industrial, normally you use it as a feedstock. So yeah, it could be also in a valley. Any other question in the room? We have more questions on slide, huh? But I want to give you the possibility. Yes, Mark.
Let me first congratulate you on the outcome and the impact so far. We are interested in increasingly distributed, renewable-based power generation and also the use of decarbonized molecules in the overall energy system. Decarbonized molecules used in fuel cells, used in high-temperature fuel cells. There I applaud your initiative on trigeneration, particularly the reversibility. But another type of high-temperature fuel cell is not at all mentioned, molten carbonate, where you can do CO2 concentration and even negative CO2 emissions or balances can be achieved. Any comment on why there is nothing on MCFC? At least not presented.
Yeah. You go? Yeah.
There is no reason. It's not. I mean, the SRIA is defined in a way that is technological neutral. Okay, it has KPIs which are linked to, if I'm right, at least for a stationary on PEM and solid oxide. But it's also very clear about the fact that it's not close to any other chemistry, any other technology. The emphasis that the SRIA has responds to the landscape of the European community as well. So we have taken that input, we have taken that into account when defining the SRIA, and it was not, that process, if you want, did not result on concrete commitments or KPIs for this technology. And that's why it's not reflected in the SRIA. And probably this is why you have not seen any projects, because we don't have on that technology. But it's not close to it, so we could embrace it. But these are the reasons why probably we don't have a project, and probably why we don't have the KPIs per se for molten carbonate, for instance, in Europe. But fair observation, yeah.
We know historically, to complement, there was some activity on molten carbonate at the beginning of the GU with at least two industries in Europe, with Ansaldo and the other one, MC something. MTU, thank you, yeah. And we know that was happening, but then I don't know, for reasons out of our control, they stopped their activities, and there are still some activities, you know, we also know in US and Korea, but yeah, this is not something that we have in Europe anymore, I believe. Yeah.
Negative CO2 balance.
Yeah. Point taken, Mark. Thank you. Good. I would like to, yes, last question from the room.
Thank you very much. Yannis Verkmanis from Turquoise in London. Very good overviews of what's happening. Thank you very much. But could you say some words about what's next?
Yeah.
Yeah. What's next, and where perhaps each PO sees the main priorities?
Yeah. Thank you very much. I mean, on purpose, I haven't said much on what's next in details, because I mentioned at the beginning we have a plan for 10 years. This is our SRIA, Strategic Research and Innovation Agenda. But that's just a bit to comment on how we implement the activities annually. We have calls for proposals, so we publish call for proposals where we offer grants, just a bit for those that we are not yet used with our program. And we are running the call for this year. For next year, for 2023, we've gathered already at the beginning of this year, so 1 year in advance, the strategic priorities, get them approved by our board. In our board, as you can guess, is the European Commission, industry, and the research. And then developed call topics for next year. We are in the process of finalizing that, and we plan to publish the new call 2023 in January. I think that has been already said also yesterday. With a deadline for applications in April, May. That's what we give, normally 3-4 months. and then evaluation happening in the summer, and signing new projects, new grants by the end of the year. We go back to our normal cycle. Again, for those used with us, that's what we did in the past. We will plan to have one call per year, so we will not have multiples. And the call of next year, it is foreseen to be about 200 million, with some additional maybe funding for the valley from the Repower EU, which I just mentioned, of about 60 million. So 260 million will be next year. The more details than this, I cannot give at this point because it's under the approval. The plan is to continue like that also for the other years to come, 2024, 2025, etc. Although yesterday they were hinting about the academy, and that was one of the questions in the slide. Yes, a hydrogen academy call will be in January, for example. And some other things we have also mentioned through the presentations of today, what we will and in which direction are we going. But this is the most I could say at this point about the future. So I would propose to stop here because I think everybody's hungry. We will get back, and I would like to remind you about the Slido and the fact that as of this afternoon, we will be split in this room and in the other room. So please split according to the sessions you would like to follow. And before you all stand up, I would like to give a round of applause again to my team. Really, 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 really proud of them. And I would like also to invite the others because I really want to take a picture. I hope you are with us. Yes. Claudiu, please stand up. Eleni, Pietro. Where is Eleni? We missed the only lady that she's with me, and Luca. You see, I have a men team, but I have one lady more with me. So please come here also, because I would like also that everybody know you. I'm very proud of you. And of course, in addition to them, Kostis and Petros, the knowledge management people, all with the numbers behind us. So that's my operational team behind all of this that you have seen this morning. Thank you very much to all of you. Very proud of you. Eleni, quick. Thank you very much. Thank you. Enjoy your lunch.